Hey, welcome everybody. My name is Kevin. I'm the training coordinator with the Association of State Floodplain Managers, and I'd like to welcome you to our webinar today. We're going to be talking about HEC-RAS 2025, of course. Before we do that, though, I have a few admin announcements to go over with you. So first, I just want to talk a little bit about participation. We've got a really big audience today. All of the lines for the audience members are muted. It would just be kind of too much cross-talking, but we do want you to participate. So to that end, we have a Q&A feature here within the Zoom software. If you have questions about anything you see today, we want you to use the Q&A area. There's also a chat feature. Um, Try to keep your questions over in the Q&A area. You can put them in the chat. It's just harder to keep track. So if you have a question or comment, go ahead and drop it into the Q&A area. And we'll kind of, um, as I understand it, I think we're going to be trying to answer those in writing throughout the presentation. And then if we have a balance of questions at the end and we have some time, we'll do a dedicated Q&A at that time as well. But suffice to say, please use the Q&A area. We're also going to have a couple polls for you today, so just want to calibrate your expectations there. It'll pop up on the screen, we'll prompt you, you'll have enough time to respond, and then we'll kind of close it and move on. But I just wanted to let you know those are coming, so please try to be ready for that. Continuing education credits, certificates of attendance, things like that. This is approved for CECs, for CFMs, and for AICP credit as well. So if you're on with us for the duration, if you're engaged and participating in the full event, you'll earn those credits. If you're a CFM, we're going to apply that to your records automatically. And we'll also be issuing you a certificate of attendance. So we'll email that out to you in about a week, and it'll have the event number. If you need that AICP credit, you'll be able to, when you get your certificate, it'll have the event number that you can look up and get that credit as well. So credits and certificates are coming. It's going to take us about a week or so to turn that around. And just last comment, this is an ongoing webinar series, and we do appreciate any feedback you may have on it. So if you have any ideas you think you might want covered for this, you can always reach out to us, alan@floods.org, and he'll take that feedback into consideration as we develop this webinar series further. But so without any further ado, I want to introduce Alan. He's going to go over this subcommittee's work, the webinar series, and our topic and speakers. So Alan Luloff, Senior Project Manager in ASFPM's Flood Science Center. Alan, take it away.
Good afternoon, and maybe good morning in some parts of the country. We have ASFPM is a very strong supporter of the Cooperating Technical Partners program that FEMA has introduced. And the board actually passed a resolution supporting the Cooperating Technical Partners program a number of years ago. And at the same time, we actually created a subcommittee of the Mapping and Engineering Standards Committee. And this subcommittee is co-chaired by Joanna Rolfe with the state of Kansas and Dave Gannett with the state of Maryland. And Dave, by the way, is retiring soon. So sometime in July. So shortly we'll have a new co-chair of this subcommittee. And you can see here the goals of the subcommittee. And one of the major things we do is we put on these quarterly webinars. And these webinars are recorded. And so we host these webinars on a quarterly basis. And as you can see, we average around 600 people attending these webinars. Today, we're going to be, I think, quite a bit above that. There's a QR code, and we record these webinars. And so you can go to the ASFPM Flood Science Center web page, and you can find the recordings for all our past webinars. If you go to that QR code, that'll take you to that location so you can see all the past webinars we've conducted. And then I want to highlight, this is Laura Algio, and on the left, obviously. And here, this is from a few years ago. I found this photo on Google, and she's presenting a achievement award to Carrie Johnson. Laura Algio is Todd Davison was the supervisor in Region 4 when the Cooperating Technical Partner Program began, and he jumped in very vigorously and got all the Region 4 states to be cooperating technical partners and did a great job. Those states now have done a phenomenal job in moving forward and actually have built staff through this process. This is Carrie Johnson with the state of Connecticut receiving an achievement award. So that's just one of the things she instituted over her years as the CTP program coordinator. And unfortunately, her last day was May 23rd, I believe, and she is retired from ASFPM. So we're very sad to highlight that today because she was, can't tell you how good she was to work with, and she accomplished really a lot to move the CTP program forward. So today we're presenting on HEC-RAS 2025, and we have three speakers today that I'll introduce. And first, Alex Kennedy, he's the lead developer of the HEC-RAS 2025, and he's been at HEC for 14 years, previously working on RAS Mapper with our meshing terrain and mapping technology, and he is a Master's of Science in Computer Science from UC Davis. And then we have Cameron Ackerman. He is a senior hydraulic engineer with the U.S. Army Corps of Engineers, the Hydraulic Engineering Center. Cameron's almost 30 years working at HEC have focused on the use of GIS to assist in water resources modeling and the development of the HEC-RAS software. And then we have Zach Morris. He is a senior software developer with the U.S. Army Corps of Engineers Hydraulic Engineering Center, who over the past 5 years has worked in the modernization of HEC-RAS into HEC-RAS 2025. His technical area of expertise includes C+, I think it's C+ programming, and UI design and GIS applications. So those are our presenters for the day.
Awesome. Thank you, Alan. So this is Kevin again. It's been kind of a longer windup than usual here, but I do want to let everyone know we're going to do our first poll while our presenters get set up. So you'll see that up on the screen hopefully here. And there are 4 questions. Take your time, take a minute, work through it, and then we'll take a look at the results, and then we'll be underway. Thanks, everybody. Okay, so I ended the poll. If you didn't get a chance to respond, don't worry about it. Um, Not the end of the world, and there'll be some more, but I just wanted to, in the interest of time, move on. Can you all see that? Are you able to see the results there? Cool. Okay, great. Well, that's going to be really helpful as we move forward. So thanks for weighing in there. All right, Alex, take it away.
Wonderful, thank you. Uh, Good morning, afternoon, everyone, wherever you happen to be in the country. My name is Alex Kennedy. I'm the lead developer on the RAS 2025 project, and we are coming to you from sunny Davis, California at the Hydrologic Engineering Center. Before I start off the set of demos today, I kind of want to give the standard software demo preamble. Rule number one of software demos is that you never give a live software demo. Murphy's Law applies. Things invariably go wrong. And this is an alpha product, right? So I would kind of like to ask for your patience today as we're going through these software demos and reminding everyone that this is very much still a work in progress. We're writing code every single day, squashing those bugs, and that's been a major, major focus for us. So with that, let me share my screen. All right, sweet. I hope everyone can see that. And I'm going to launch the software here. And the first thing, besides dark mode, that everyone should notice is that we want to make everything we can in this software a geospatial GIS point of view, and that starts from the opening screen. You're looking at a list of recent projects, screenshots of where you were in the map the last time you were working on this project. These are all selectable. These are all highlightable. You can scroll back through a time history. You can see the models that I've been working on and testing recently. On the left-hand side are your four major entry points into the software. New project and open existing project should be fairly self-explanatory. One of the kind of neat things about open project is that it does technically open version 6 models. Uh, this is very much a work in progress. It's going to get a lot better. But if you try it out, we will do whatever we can to migrate the pieces of data in your version 5 and version 6 model that we understand. So simple boundary conditions should come in, terrain should come in, geometry won't because of some of our mesh generation changes that we'll discuss a little bit later. Um, Example data sets is one of the areas that we are really, really proud of. So on top of our GIS geospatial focus there, another very large theme as we're working with the software here is how much can we do for this next generation to integrate network data sources, right? So that comes from USGS with terrain data and flow gauge data. That comes from NOAA and National Weather Service trying to get precipitation data embedded in the RAS right within the user interface itself. And that comes from a lot of data hosted here at HEC. So we have these example projects. They have names and descriptions, obviously, but we're working on adding a tagging system. So you can come in as a new engineer learning the software and say, oh, I really need to know how breaching works. I really need to know how sediment works with breaching. All right, let me start to filter down through my set of projects and say, is there any project that has both breaching and sediment? Great. Here are my three example data sets that filter that criteria. So each of these are clickable. I won't be doing that right now, but that when you do click it, it downloads directly from our website, just that one example project, and extracts it, opens it up in your default project folder, and launches you right into the software. So I'm going to be hitting back here. GIS mode is still a bit of a work in progress, but this is one of the things that as we were developing the product ourselves, we really started to get used to all of the raster and vector processing capabilities that we needed to develop for the rest of RAS. So someone has a product in version 6 that needs to convert a raster file, needs to quickly open it up and see, hey, does this have the right terrain data in it? Our GIS mode launches straight into the software without a project. It's ephemeral, so when you close it, it just goes away. We are hoping that this can be another learning tool as we add capabilities to raster processing and vector processing features as you have different data sources and really lets you quickly scan and say, okay, don't build a fake model. Don't remember where I put it. Don't remember to clean it up. Let me just quickly see what this file is. But we are going to be starting with our new project button here. one of the major focuses being geospatial information, we are forcing you to select a projection up front if your model is going to be a projected model. So you always can hit the local projection button for tabletop studies, or if you're not interested in GIS data, it's still XY coordinates. You still have to draw your mesh. You still have to draw vector data on a map, but you are making a pretty concrete statement here that this is a fake data set, or I don't care about integrating with any other geospatial data when you select the local option. But today we're going to be in the more normal projected option. Because we are forcing you to select this up front, we have put in quite a bit of effort into improving the ways that you can select a projection. We understand that this has been a pain point for people in the past. So among a search option, which is still improving, and a map-based option, which doesn't currently work, we have a pick from a file. Any file that RAS recognizes has a projection embedded. This can be another project file. This can be a TIFF file. This can be a .prj standard file. Any file that we recognize has a projection, we can extract it and use it for your model. So no more do you have to go to the web and find some random PRJ file or find a shape file that somebody else wrote to try to get this PRJ file. Anything that you know has the right projection, you can drop it on here, and then we will expand out a summary. And in this case, it's an AEA projection for this model. Today, I'm going to be working in the Ohio Miss area, and because I have quite a few of these from other examples, I'm just going to put the number 3 on there, and then of course you can add a description, which will save. I'm going to create the project here, and very first thing you should note is we are jumping you into a map at approximately the center of mass of the projection, because this is AEA is a very large projection. The latitude isn't in the area we want, but the longitude is approximately correct. These maps are from the OpenStreetMap dataset there, so they're kind of communally worldwide contributed to. And we have a copy of those hosted here at HEC, and it is dynamically downloading all of these roads, streets, lakes, building footprints as you are using the software. So the base map button is in the upper right corner here. I can toggle it off. I can expand out and add hillshade, for example. Looks like that zooms me out. This is we're really, really hoping, as part of our network connectivity and geospatial push, that this base map button always being available to you within the UI is going to be very, very helpful. Broadly, we have a map view in the center of the screen and our layer list, our model view on the left-hand side. This should look very familiar to people who have used RAS Mapper before, kind of our version 5 and version 6 push into a GIS-focused world. And just like in RAS Mapper, first thing you should probably do when you start a model is create a terrain. So I'm going to create a terrain here, just going to let it be the default name. A terrain is an empty bucket to receive information. We allow a variety of raster and vector data sources. Right now, our vector stack, including our vector modifications, aren't ready to show yet. They're not quite complete, but our raster stack is pretty robust. I'm going to select the bucket, this terrain bucket that I just created. And on the right-hand side, you'll notice that the components tab reacted to the layer that I just selected. So the ethos kind of behind the tabs that are on the right-hand side is that they react to any layer that you select in your model, in your tree, and they are displaying relevant information. And broadly, the separation is that the components tab here is about layers that will affect the model results. So in this case, what affects it for a terrain? Well, it's the tiles that go into it. We'll show that in a second. And the layer tab is all visualization based. So this is any plot options, symbology, hillshade, information like that. So if you are ever interacting with the geometry, for example, and you would like something to highlight cell indexes, right? That does not affecting the model. That's a visualization option. So you should be looking in the layer tab broadly. The components pane, you can hit the plus button, and we have a couple options for how to bring data in. But drag and drop also works everywhere in the UI where it makes sense to. I have on my data set here, I have some terrain tiles that I know are relevant for this model. So I'm just going to shift select them, drag them, and pop them onto the green button here. For all of these data importers, raster, vector, whatever it is, we again want you to be geospatially anchored. We want to make sure that you know that your projection is correct. We want you to know that your unit system is correct. We want to show the data where we think it is before you ever have a chance to preview it. And each of these tiles are individually selectable, and you can see where they are in the map to make sure that you're not importing duplicate data, to make sure that you know where these data sources are coming from. One of the major pain points in version 6 and before is that the terrain is a fairly static entity there. You can draw levees and channels after the fact, but really when you're bringing in raster data, you can only do that once. So if anyone ever sends you higher resolution bathymetry, if anyone ever improves the terrain raster model, or if you just make a mistake and put the wrong layer, lower resolution on top of higher resolution, then you have to redo that entire process. And that can be a very, very onerous and slow operation for large data sets. So we tackled that kind of pain point very, very early on. And right now, I actually don't care what order this comes in at. So I'm going to hit import. Our raster processing, we have put an incredible amount of time into. So that's been something we're really, really proud of. It's 25x faster on average for bringing a lot of these files in. And whatever order the layers came in as, you can reorder them after the fact. So I happen to know that the USGS 30 meter is should be at the bottom of this data set. So I'm just going to click and drag, throw it at the bottom, and it reordered seamlessly. So for property tables, for visualization, for mapping, if by all measures, it is below the other terrain layers that I have. One of the other kind of, I'll say, broad categories of tools that we have here that should be kind of a familiar home base for people who are used to 6 is that we have a dedicated editor for each layer type that you can access either by right-clicking your layer and saying Open Editor, or when it's selected, it'll show up as a button on the top. So I am going to open the terrain editor, and that brings a more dedicated, focused view of this terrain. Now, it's still geospatial, but this is where when we have more advanced terrain vector mods, if we have more metadata per file, as we want to show you that, this is where you see that kind of information, and then you can go through and see, hey, where exactly are the tiles here? Did I capture the bathymetry correctly? That sort of thing. So I'm going to back out of the map here. And for the next portion of the example, I'm going to open up a smaller data set because there's some network kind of related issues here. I'm going to open up Muncie from our example data sets. This is downloading straight from our website. It happens to be cache on my machine, and after you download it once, it'll be cached locally on your machine. So the opening up should be almost instant the second time you do it. And a much smaller data set, obviously. We are going to import an LCD, and I want to show you another major focus of ours in this classification network connectivity. So I'm going to add a classification layer. This is our broad category of layers that are integer codes that are describing the world in discrete states. So I'm just going to create it like many other layers. This is an empty bucket until you add data to it. I'm going to select it. And on the right-hand side here in our components pane, we have this helpful button at top, import NLCD, and it's the 2021 dataset. So if you've ever had to download the NLCD from their website, it is some 20 gigabyte zipped up monstrosity. It takes a very, very long time. And if you misplace it on a shared drive and you have to go redo it again, that can be an afternoon killer, believe me. So we wanted to tackle this pain point head on. We downloaded a copy of the 2021 data, and then we decimated it, tiled it, and hosted it on our servers in a way that is really, really easy to pull in just the subset that you need. So I'm going to hit the import button, and within a few seconds, this is not, there's no kind of software tricks here. It wasn't on my machine. It downloaded very, very small, clipped out copy of the data for us right here. And it applied the standard NLCD kind of color ramp for medium density, high density urban. So from here, these are classifiers. This is a integer representation of the world that the NLCD dataset references. And yes, you'll probably, if you're doing more detailed hydraulic modeling, want to go in and digitize a channel. We have our classification polygon set up there for you to draw more accurate regions, but as a broad starting point, it does reasonable for supplying end values. The end value layer in version 6 was very much tied up with the classification land cover data set. So you could start off with raster or vector data, but they were hopelessly tied together from that point forward into the model. And that led to some confusion and misunderstandings as we wanted to attach more data sets to it. As we went through percent impervious, as we had soils and infiltration data, we wanted to start kind of attaching more parameterizations to our description, integer description of the world. So we have separated these two in 2025. I'm going to say create n value layer from this layer. And what this does is in a moment creates a very small shell of a file that looks at those land cover values and provides a reasonable opening guess at n values and uh, displays it on your screen. Because the parameterization of n values is just reinterpreting, it's just a small table that says this integer code means this floating point n value. That is just a very, very small table stored on disk. We're not copying the data. So as you improve your model, as you digitize your channel, we forever holds, we're referring constantly back to the base data set. So your n value layer will seamlessly update as you improve your classification description of the world. With this, I think that's about where I wanted to end this portion of the discussion and throw it back to Cam for his modeling section.
All right, thanks, Alex. All right, I see myself on there, so hopefully you guys can see everything I can see. Everybody see a current version of the RAS 2025 interface?
Yeah, it looks good.
Okay. All right. So Alex gave you a brief overview. We have a motto. We always like to tell you what we're going to tell you, show you what we told you, and then remind you what we told you. So Alex went kind of in detail. I'm going to try and cover some of the stuff that Alex went over and get you all the way through the modeling process so you can see what you're looking at is not smoke and mirrors. We've come a long way in being able to develop a model. And then we wanted to, at the end of this, I'll show you how you can use some of the tools we have in RAS25 with the current version 6 version of RAS. So here you can see the main interface. And so from a real practical view, we're just going to blow through how we'd create a model. And so I'm going to create a project. And so Alex already showed you how to do this. So ASFPM. He's got some really great tools here. We're not going to get into them, but this is one of the things to play around with. Download it and play with it yourself. Whether you want to use a well-known text to develop your projection file. We've got a search tool that allows you to go out and search. If you guys are familiar with spatialreference.org, there's lots of different good ways to get projection files. We're trying to integrate them all to make everybody's job a little bit easier. And so I'm going to just throw a projection on here off of my other monitor and create my project. So my project has been created in California State Plane Zone 2. I'm using a local California state projection. And we're going to go to Yosemite. Whenever anybody comes to California, they go to Yosemite. So I figured might as well go there today. And so the first thing we can do is we can zoom in using the base map, or because we're really a geocentric model, we can go ahead and we can drag and drop a shapefile onto the middle of the map. And you can see the shapefile came in up here. And so we can either zoom into the shapefile that came in, or we could just go to the data set, which is called boundary, and we can right click and we can zoom to it. So it can take us right into where we want to go. And then the first thing we're going to do, as Alex showed you, was create a train model. So we're going to do that really quickly. In our case, the thing I really wanted to show you guys is I wanted to show you guys how the cool USGS data importer works. It's very similar to the one that works in RAS6. However, due to, we're going to say, federal budgetary changes, I've been having some trouble with the server. So we're going to give it a try. If you guys are having trouble and the tool, you try it out yourself and the tool does not work, you'll see a little message up here in the upper left-hand corner. It says that the servers are probably down. And so I played with this in the last 3 days hundreds of times, and it has worked half of the time. So the USGS has got something going on. So we're going to cancel out of there, and I'm going to walk you through it. I made a presentation this morning. I'm just going to walk you through what I wanted to share with you. One of our software engineers developed this really nice tool. It's nearing completion, but this is kind of the way it works, where at the bottom right now there's a query option which will go out, query the server, identify where data is available. Once that successfully works, you would see the map will be populated with all the different tiles. This can be a little bit overwhelming, and so the really cool thing that we've added is the ability to filter based on either tile size. So that's like, hey, I want the whole quad, or I want smaller chunks. And so you can do it by tile size, or you can do it by resolution. And that's what I normally focus on. Normally I want to grab the meter data or the original data. So you can do a filter just by clicking on the filter button up in the right-hand corner. It'll give you a drop down, and then you can choose the data you want to look at, narrow it down. In which case it'll come up with a nice tile pattern that you can recognize. Now the thing that I wanted to do the demo for was each one of these are interactive. If you're used to using version 6, you select all the tiles you'd like and say, go grab them all, which is cool. But we've implemented a new tool here where you can essentially grab there'll be a little cloud icon that'll pop up, and you can download each individual tile as you go, so you can see how far out do I need to go. So you can see from this this view of the Yosemite Valley, I probably would want a little more terrain up here in the upper part, and so I would go and click these next 2 tiles, and that would give me a full picture of the valley floodplain floor. So the interactive nature of this tool, I think, is really great. Once you've done that, then you just click the import button, and that works how Alex showed you earlier. So we don't have terrain, so I'm going to go out and I'm going to add my own terrain from disk, because like I said, I've done this many times, and I have lots of data on disk for this area. So I'm going to bring it in. You can see on the importer we have a few options. I always like to round my data. I don't need 6 or 7 decimal places. So I'm going to go ahead and round it and import the data. And as Alex said, the import process is a little bit more rapid than in the version 6 software. So now that we have our terrain model, what's the first thing we're going to want to do? Well, the first thing we're probably going to want to do is we're going to want to develop the 2D mesh for the study area that we're looking at. And so I've already got that developed, right? We already saw that come in already. Now we're developing tools where we can copy and paste between different layers, but we also have import tools. So I'm going to create a geometry, and we'll just call it G1 because we'll eventually create geometry 2. And we are housing the data in our geometry in what we're calling a conceptual mesh. So let's start by bringing in this parameter, and we'll talk about what that looks like as it comes in. So I've got this boundary shapefile out there. Here's what it looks like over my study area. Looks great. We have a couple import options. We'll look at those later, but we're just going to import it. And I'm going to kill the task because otherwise it keeps spinning. There it goes. All right. So that has come in to what we're calling the conceptual mesh. So the way we're developing our framework for 2D modeling then is comprised of a series of nodes and arcs, which will then form regions. So in this case, I simply have one arc, which is continuous, forming a polygon. You can see the node here in purple where the mouse is. And so this one arc, which happens to close it on itself, has one node, but we can use that to model our 2D area. So from this point, we can go in and start editing this conceptual mesh, and we can add more arcs, which we're going to do in a little bit, but we're just going to get started with just this simple polygon. and we're going to say, how do I want to model this? Right now we have essentially three methods. We can represent our 2D domain with quads, with triangles, or with a Cartesian mesh. And then we have this fourth option sitting over here where we can put holes in the mesh. I know it's very exciting for a lot of you guys. We will be able to put holes in the mesh if you're trying to model a big island or a big building or something. That will be something that is something that you can do now, but that's available. So I'm going to start with Cartesian. I like the idea of 4 sides. 3 sides just means more faces, more computation time, unless I make the cells much, much bigger. But I like Cartesian meshes. So I'm going to start there. And when we do that, we can enter a cell size manually, or we can use the default and then start increasing it or decreasing it using some quick links. After having played with this a lot, about a 200-foot cell size works really nicely. Now, as I've selected this region, as Alex said, we have these component tab over on the right, which is going to allow you to access some of the parameters we use for the meshing capabilities. So here for Cartesian, you can see we have a primary cell direction, a secondary cell direction. You can rotate the mesh if you'd like. There's a cell stretching rate, how fast you want cells to grow from your primary rate off to if another arc was in there. And then we have some default post-processing capabilities. But the post-processor won't make sense to you until we generate our first mesh. So let's generate our first mesh. So this is what this is going to look like. As you can see, we've got nice quads along almost everywhere except for the perimeter. The perimeter, we're not able to build a quad because it's got doesn't have straight edges, and where some of those computation points would be awfully close. So in that case, we come up with little triangles and stuff. So while our mesh generation, we might refer to it as quads, or we might refer to it as Cartesian, there's going to be triangles in there to help you transition from one shape to another. So for right now, let's call that good. We'll get back to the post-processing options in just a minute. The next thing we need to do then, we have our geometry. Let's say that's great. What do we need next for the geometry? Well, we're going to need some sort of end values. And as Alex already showed you, it's very easy to get started. So I'm going to add my classification layer. I always call it land cover when I'm doing end value work. So I've got my land cover layer. Once I've got that selected, I can go and import the NLCD data set. Comes right in. Now, is this the land cover data set that we want to use for our final model? It is not, but it's a great place to get started. So using this data, I can quickly get my hydraulics model up and running. If I was an overachiever and I didn't want to just get it running, I wanted to get it running well, what's the first thing you would do? Well, you'd probably go in and you define some areas. So this is where we would use cool tools to develop the channel. So we could digitize and create the channel, and I'll show you guys the digitization tools in a minute. We're not going to do it right here because that's we don't have enough time to go into all the fun details I'd like to do. We could do fun stuff like we could come over here and we could turn on our satellite imagery, turn down that opacity, and then we could, come on, buddy. Once we got the opacity set just how we liked it, we could zoom in maybe to a particular area, and maybe you wanted to really model these parking lots and put in a low end value for the parking lots, and you wanted to come in here and put a really high end value in for the lodge. In concert with the aerial photo and your land cover data set, you could create your own classification polygons. We're not going to do that today. We don't have enough time for that. So right now I'm just going to use what I've got, and I'm going to create my end values from it. Those end values are now exist. I can see exactly what they're going to be. If I want to work with the layers, so a lot of layers, we have our components tab. That's where we'll be developing these end values. And by default, we have a little button to set these end values. The end values that we're using, they're just a start. They are just average published values. So all but the developed everything except for these developed values, they all came from chow. So they're just an average value for that land use type. So we can do that, but we could also come into the layer if we wanted to visualize things a little bit differently. So if we didn't like the colors that came in here, we could come in and say, we want to edit the symbologies, and we could change the colors that are associated with the end values. So right now, how things are is components are really like data I need to enter, data that are important, and then the layer tab would be how do I want to visualize that? That's how the interface is kind of organized. Okay, so we've got our end values. What's the next thing that we need to do? This is where I like to interact with the class. You should be thinking, what am I going to do next? Well, the next thing I need to do is I need to establish my flows, some sort of boundary conditions. So we can come over here to the boundary conditions layer. I always like to give it a unique name so that I know I did it. We're going to set this up to run for just a 3-day simulation. I'm not going to mess with the time windows, but you can set obviously your time window to be whatever you'd like. And so now we have a layer, a boundary condition layer, and now we can establish boundary conditions. So to do editing in RAS, any layer that's editable, you'll see a pencil that'll become available, and then you have access to that. And so if I want to set my upstream boundary condition, I will double click to start, double click to end. My boundary condition is created, and now you can see I've got a little question mark. That's our way of trying to tell you, hey, we got to do something. What do you want me to be? So we can click on that, and right now our quick links take you to setting a stage hydrograph, a flow hydrograph, or normal depth. We're going to do flows at the upstream end. And so once we've done that, you'll see in the components tab, we will have a boundary condition that has been added. I'm going to call this inflow. So I know where I am. It's going to be my inflow hydrograph. My data, so we've got our time window that has been set by the boundary condition editor. The data that I'm going to paste in here is going to be 15-minute data. So I'm going to be specifying the interval which I want to enter the data. And I could do this by hand, but it's a demo, and we would never do it by hand. In this case, we're going to do it straight out of Excel. Hopefully, in the near future, we'll have lots of different ways for you to enter data in. But we can copy and paste, and the data is in here. We'll be adding various ways to view this data. The way I like to do it is I just want to make sure that all the data went in there, so I could come in here and I could grab the scroll bar and go to the end. Or if I wanted to see real quickly, we've got some plotting that we're working on. You can see that that blue line is plotting. We also, that's part of the standard editing tools. So this whole component pane, we can get to an editor version of that. So if we go to open editor, you can see it opens in the full window view. If we want to go to the boundary conditions themselves and click on one, we have a fully integrated editor. So we're still working on exactly the semantics and the cadence of how this is all going to work. But this is one way you can see all your data all together. But like I said, I typically work off the tree and work off the component editor. Okay, so we entered the upstream boundary condition. Also going to need to add some sort of downstream boundary condition. So we'll add here down at the downstream end, we're going to add a normal depth boundary condition, going through the same type of data entry. Here you can see over here, I'm entering the friction slope for the downstream boundary condition. And it's going to slide off screen, so I'll bring this over. I'm going to name this downstream, just so we know where we are. Okay, so that's my basic run. It's been set up. I've set up a simple Cartesian grid. I've set up boundary conditions. I have end values. Now, the one thing I didn't do, and I often forget to do that, is I need to come over here to the geometry and double check that the end values were selected. We should be setting the default as we add the first terrain, and as we add the first end value later, that should get set. Sometimes I forget to check that, but that's always good. So I've got all that set up. Now I can create a plan and run it. So we'll call this run 1. We're going to select our geometry. We're going to select our boundary conditions. The time window is going to come in from the boundary condition. We can override that if we'd like. Maybe we want to have a little bit shorter time window, but we're just going to leave it for now. Say create. And now we have a plan to run. As you can see, once I make this plan active, I get a compute button and an editor up at the upper left, but I also get all the components down on the right. So the components tab is intended to show you like things that you really should set, maybe not all the details. And then if you want to get into the details, that's when you would go and open the editor. So right now I'm setting this to 8 cores. We're not really going to worry about the computation interval. RAS is explicit, meaning it's going to figure out what time step it should use in order to satisfy the Courant condition. Again, we could talk about the Courant numbers for a lot of time, but we're not going to go through that today. So we don't really have to worry about time, the computation interval. We can specify a mapping output interval, how many processors we want the computer to use. I'm going to leave it to 8 and then hit compute. As this runs, a little compute log will pop up and let you know what's going on. Obviously, the compute log is important because it's going to tell you, hey, did I need to recompute the hydraulic tables? We're going to be computing information at every cell face. If we don't have to, we don't want to, that's expensive. So we're not going to do that if we don't have to, but the interface will tell you whether that's happening or not. It's going to give you more information and then let you know when it's done. That run took 20 seconds. So now we can come in here and we can go look at our results. So if we turn on our first result, we can turn on, in this case, depth, and then using the scroll bar up above, if I could grab it properly, we can see how the simulation simulated, how it went. We can also come into the map and right click on any place and we can query the time series. So there's a plot of where we are. And then if I was scrolling, let's see if I can do it. I'm not really great at all the docking windows, but let's see if we can do it here. Get rid of that guy. So if we're looking here on the map, and as we animate, you can see the little bubble following our plot where we're going. And then you can also see the map down below. And then you've also got right now it's a black dot to show you where we are in the map. So we're working on very integrated mapping and plotting. Okay, so that's the first part of the demo. And you're like, yeah, that's great, Cam. You didn't really show me anything that was too exciting other than the cool, sweet interface that we now have access to. What happens if you want to do some detailed modeling? So let's get into a little bit more complicated. When we do modeling, we always set up a generic model, right? Just to get an idea for what the floodplain looks like. Now we know where the river is. We know where the main channel is. We might know where some areas of rapidly varied flow are that we need to concentrate on. We know kind of where the gradually varied flow areas are, where our cell spacing can be larger. So let's just do a real quick version of that with this model. So you can really easily see where the channel is. And so the next step would be, we'd probably go in and we put in a channel. We would have gone into our land cover layer. We would have made better estimates for our end values for that channel, and probably some other places. You can see there's high ground. So we probably would have gone along all these roadways. We would have put in high ground, things like that to really improve our model. But right now we're just gonna have time to just demonstrate how we could do that first part. And that's gonna be, we're gonna add a channel. So we've got a great option over here in the geometry where we're going to clone our terrain. So I want to use the same geometry. Creates a copy here. I'm going to rename it. So we're going to call this refined. Okay. So now we've got 2 geometries. I'm going to turn off the first geometry. We don't need to see it anymore. We're going to be working on well, we should be working on our geometry. It looks like our copy didn't work slickly like it should, but that's okay. And what we're going to do is we're going to add this channel in. Now, I've already gone to the trouble of digitizing the channel, so you guys don't have to watch me do that. So we're going to come over and we're going to do the same thing we did before, and we're going to import a shapefile of our channel data. It's called channel. It's right here. So we're going to grab that guy. Shows me what it looks like, shows me where it's going to go. Now we have 2 options On the importer, we have an import and merge, and we have an import without merge. Import without merge works exactly like you think it would. It just brings in the shape, throws it on top, and then it's your job to take care of intersections and create nodes so that arcs can intersect, that type of thing. Import and merge has been developed by our buddy Zach, who's going to be speaking next. And that goes through and it tries to fix all the intersections with all your arcs. Now, this is going to work great for really simple data sets, but for very complicated data sets where you might have arcs that share a boundary, but they don't actually share a boundary, it's not going to work so great. So depending on what you are trying to accomplish, you can use the two different modes. We're going to play with the import and merge one today because this is a relatively simple data set. I have one polygon coming in on top of another polygon. But when that comes in, what you're going to see, we'll start down here at the downstream end. What you're going to see is we now have this channel came in and nodes shown here in purple were created for me. Okay, so we've got a region here up top, we've got this channel region, we've got this other region, and then this lower region. And so what we're going to want to do is we're going to want to go through in this case, and we're going to want to get rid of this region. Now we might want to edit some of these features, but for today we're doing simple editing because Alex said rule number 1 of a demo is never give a demo, or never give a demo live. We have the same problem up here at the upper end, so we're gonna, we are going to select it and we're going to delete it. If we wanted to edit these lines, then to edit a line, we are simply in edit mode, grab an arc, double click it, and now we can edit. So I can go in and I can smooth things out if I don't like what something looked like, right? So simple editing tools. If I wanted to create another region, then I could just double click, create an arc across these regions, and a new arc would be formed. A new arc would be developed, creating new regions. All right, so that's great. This looks pretty good, a pretty good first shot at having a channel and overbank regions. Now we're going to go through and we're going to make sure that the meshing is going to happen kind of how we want it to do. So I'm going to go through and first I'm going to do this upper region. I'm going to check it. It's still in Cartesian. I still have a 200-foot cell size. That's great. I'm going to check the bottom region, which is not going to be right. It got the defaults. So we need to work on like remembering some of the stuff, but that's cool. We just set it to Cartesian. I'm going to set it to the 200-foot cell size once again. That's great. And then what did we want to do in the channel? Well, the channel, maybe we want to do something a little bit different. So this is where we want to highlight and demonstrate to you how our the quadrangles work. So we're going to change that to a quad region. What I'm going to do is I'm going to say I want those cells to be about 200 feet long. And then as far as how wide or how many are across the channel, I'm going to do something and I'm just going to go kind of like an integer count. And I'm going to say, I just really want 3 cells across. And I could choose 1, I could choose 5, whatever floats your boat, or you could do it based on width. I just know this will make a nice picture for what we're working on. And then once I've got that data entered, you saw those little arrows highlight that said push it to the polygon. So I've done that. And so now I've got all my properties set up. Now I can go in and I can tell it to regenerate my mesh. Okay, so that's a pretty cool mesh, right? It looks pretty good. My initial thoughts are like, hey, well, what happened to all the quad regions out here? I've got my nice Cartesian coordinate system right here, and then for some reason it kind of goes away over here. And this is where I want to hit on. There's a lot of flexibility we've added into these development tools. The thing we're working on is post-processing capabilities. So for some of these, for this region, for instance, we need to go through and we want to merge some of these triangles. Maybe I don't want them to be so small. So I can come in and I can add, I'm just going to replace the default one. I can add, there's different properties and we're adding better editors for this, but I'm going to add the merge capability. And it's only got one argument, and that's just a threshold argument. And I'm using the value of 1.0, which means if you can keep it a square, keep it a square. So regenerate my mesh, Okay, now you can see things got cleaned up. I don't have as many small cells out here. And so there's lots of great post-processing tools. Our goal this summer is to develop some good rules, both for in general helping folks out, and so that you have a better idea what's going to happen. Okay, now if we look in the channel, you can see we've got a lot of straight lines. Not really what I was looking for in the channel. So one of the other things we could do, which happens to be one of the properties for quads, is I want curved faces. So right now this is exposed to the interface in this way. But if I want to make this look a little bit more amenable to a nice smooth mesh, I can say I want to have this be all curved faces. So I can go in there, I set that curved faces to 1, I'm going to regenerate the mesh, and now you can see coming along here, we've got a nice smooth arc. Now this turn, we're having a little bit of trouble resolving that. And so we could fix that by smoothing out our arcs, or we could break it up into another region. But let's just concentrate right here on this region. Now you can see I've got nice smooth arcs coming around the bend. Okay, so that's where we're going to leave it right now. But the idea, or for this mesh development, the idea is want to demonstrate to you that there are a lot of tools that are available to you, and there's going to be a lot of post-processing capabilities for making very complex meshes. Okay, so right now you're probably thinking, yeah, that's great. I would love to make a nice channelized mesh like this in 6. How do I do it? Well, how you do it, you use the tools we have now in 25, and then you bring it over to 6. So now that I have this nice mesh, I can come over here to the mesh itself, and I can export it. So I can export it to a version 6 mesh. And so when I do that, I should get a little dialogue. It's working. Get a little dialogue. It says that I've created a mesh, and then you can import that into RAS. So I've exported this one. I'm going to minimize that. I'm going to minimize version 25. And I'm going to bring this over here that you guys all know and love, right? Your favorite window. As you can see, it's the same. So I've already imported the terrain, land cover, etc., so you can be comfortable with where we're working. To create the to bring in that mesh, then all I'm going to do is I'm going to come in here. I'm going to create a new geometry. Okay, it's going to associate it with the terrain that's there. I'm also going to associate with land cover just for fun. I'm going to start editing the data set. I can come in here by 2D flow area. I can say I want to edit that 2D flow area, and you can see we've added a new button on the 2D flow area editor. So we don't have any 2D flow areas in here. It was a completely empty data set. So I'm going to say import mesh. I'm going to go out and find it. This is not the exact same mesh, but this is pretty darn close to what we're working on. Same file. Say open. It's going to come in. And at this point, I'm just going to close it. So you can see here, this is that mesh we were working with. We come in here, you can see, zoom over here. You can see the curved mesh. This was the same location we're looking on. What you can also see is that we have a lock button. So any mesh that you bring in from a RAS-25 is going to be locked to keep you from destroying it. You can edit this mesh, but the way the meshing tools work in RAS is that as you edit the mesh, we retriangulate and we move points around. So just to demonstrate how this works, I already have a geometry that is working, but we're going to do just to show you that, hey, there's not much to it. It does work. We can turn on those boundary conditions from a previous model. I'm going to take those. I'm going to copy them. I'm going to bring them into the boundary conditions for this new geometry. So you can see they're in here. I'm going to stop editing. So that mesh is good. Here's RAS right over here. I'm going to create a new run. So save my plan as. create a new run. I'm gonna grab this new geometry and let's see, I'm gonna go make sure diffusion wave is turned on so it goes extra fast. Give it a run. So as you can see, as that's running, this is the, oops, I messed up. Didn't grab it. All right, so we've got the new geometry. I already had a flow file created using the identical boundary conditions. I just copied those boundary conditions over. So we got the model up and running, and in about 30 seconds, that guy will be done. So I wanted to demonstrate that to you. And then I also wanted to demonstrate to you, well, what happens if we do want to edit this mesh? And then we'll leave you with some more fun stuff with Zach. So as you can see, the mesh that comes in, it might not be exactly how you like it. If you don't like it, go back to RAS2025 and edit it and then re-export it. If you do the unthinkable and you start editing this mesh over in RAS, so let's say we, well, first we have to unlock it. So we'll come in here and we'll unlock it. And then let's say maybe you don't like some of these points down here, so you're going to remove some of these computation points. Let's just say you get rid of this small triangle. You don't want that. Okay, well, now you can see the mesh. I don't know if you can see that real quickly. The mesh changed. We're now recomputing the mesh for you over in RAS6. So if you turn on the previous mesh and we zoom in, you can see how the gold is what it did look like before we edited it. The black lines are now what it's looking like now. And so you can start messing with it, try and come up with a mesh that looks just as good as what was already there. But it's going to take you a lot of hand editing. So just know you can't edit it, but if you do, you're going to lose the work that you've done. All right, that demonstrates what I had intended to demonstrate. So let's stop sharing. Let's let Zach take over.
This is Alan. I just want to remind people that if they have questions, they should put them in the Q&A portion and not the chat portion of our software. So again, if you have questions, use the Q&A.
Okay, thank you, Alan.
Yeah, thank you, Alan. Hi, everyone. I'm Zach. I am one of the developers on RAS2025. I mostly focus on a lot of our UI. And so I'm just going to be showing off some of the new cool stuff we've added in the latest alpha release, and then some stuff that's upcoming in the newest alpha release. So some of the stuff you can do now, and some of the stuff you will be able to do very soon. And they're mostly just fun, new, cool things. So I'm going to hop right into it. One of the newest things we added, one of the programmers on our team named Jet, added in velocity arrows, which is a feature in RAS6 people liked. And in addition to velocity arrows, we also added particle tracing. So you can, view the flow from your simulation. And Jet did some really cool work here. He actually added this little drop-down menu on the right where you can change different stuff like how fast the water moves, how slow it moves, how many particles there are. So if you want it to be very dense or very sparse, and some other cool little pieces of customization for the velocity tracers like that. All right, and then the next thing that we added, this is in the current release of our version. One way that people interact with our software a lot is through data tables. And so we really wanted to make interacting with data in RAS like just as good as it could possibly be. And so I'm showing this example spreadsheet functionality we added in, but all of the functionality in the spreadsheet hopefully will be functionality that lives in most or all data tables within RAS. And so this is our little spreadsheet, and what we can do is we can come in here and I can just type a number. So I'll type the number 5. And we've added different sorts of references. So I can reference the cell by typing, taking a screenshot, I guess. That's not what I wanted. Okay. I can do equals. I can reference row 1, column 1, and multiply it by 10. I typed a dash. That's an error. And get 50. And we also have, so basic math, also basic operations. So I can take the natural log of 5. And some of the other cool stuff I think that's more interesting, I have boundary condition data that I can copy and paste. And the boundary condition data is using our new data grid as well. And so it's really easy to interact with. You can use mouse arrows to click around. Just starting to type any number will start entering into the data grid. But with this cool spreadsheet functionality, I can actually reference ranges. So I can take the average of, let me actually expand this column. And Cam, your mic is still on, by the way. I don't know if you want to mute yourself. Thanks. So I can reference ranges. So I can reference row 0 to row 999, column 1, and take an average. I can do stuff like min, max, standard deviation, anything that is like a basic math operation on a set of data we can do. Other cool stuff, and I think this will be where I have more interesting data. We similar to Excel, I can reference row 335, column 1, multiply by 1.25. And so I get that updated piece of data. I can actually copy this column, select a range, and paste, and it will do dynamic cell references and stuff like that as well. And so all of this stuff we're building in-house, hopefully so that interacting with data anywhere in the software becomes a lot easier, gives you a lot more power. All right, so on to the next cool thing. Let me go to this guy. So one of the things we just added is contours. So you can now come to any result you have, right-click it, hit export shape contour. I think this is going to be in the next version that we release, not the live version, but you can click export shape contour. And you can see, again, everything in the software is GIS map oriented. This is a pretty terrible preview here, but I can see it in the preview. I'm currently using 100-foot cell sizes, and that is not great. And so I can actually just drop this to 10, and it will update the preview, which is still not great. The contour does not really seem to follow the edge of my water boundary there, but I can go further down to cell size of 1. And that looks much better. And now I can export this boundary as a shapefile for use elsewhere. And so in the same vein, not only do we add boundary contours, but we also added in terrain contours. It's been an option in the UI for a while. That just hasn't worked. And so I have this really cool terrain in Arizona that's got a lot of variation. And like Cam was pointing out, on the right-hand side here, there's the component and layer tab. So with my terrain selected, I can hit the layer tab, and there's an option to plot contours, and I'm going to set it to 150-foot interval. And you can see we get contours. I've heard requests that people want, minor and major contours. That doesn't exist yet, but all that sort of stuff we would love to add as well. Okay. That's it for the new contour stuff we added. On to the next thing. So one of the things that we hear a lot is that this tree on the left gets cluttered. And we agree that the tree on the left just builds up way too many layers. It's really hard to organize your model. And so one way that we're trying to do that is we've introduced the Project Explorer. So the Project Explorer will have all of the kind of files that make up your model in one central area. And some of the cool functionality there is in my geometries, I can actually just click a geometry, and I can see what that geometry looks like. I could very easily click between two geometries that are similar, and I can tell that kind of in the center here, one is more dense than the other. And I could also click and just see other models that I have available, quick previewing. So on that, if anyone has ever messed around with RAS 2025 yet, they'll also know we have backups. So we back up your geometry as you start to edit it. And backups are cool, but it's hard to know what backup is useful. And so now I can actually click back in time through my backups and see what my geometry looked like, an hour ago, a day ago, those sorts of things. And so the project catalog will hopefully be where we put kind of more project-centric things that are, that will help you kind of understand what's going on, what's what. And so you can see from my terrain, here's my 1 meter terrain that I have in this project. I can click the 30-meter terrain, see the 30-meter terrain. I can see the layers that are comprising the terrain and some basic file information. Even other stuff like this is brand new, but some of our data is in DSS files. So if you add a DSS file to your project, we'll just open it up for you, show you everything within the DSS file. And directly from the Project Explorer, you can plot and chart DSS records. And yeah, so the last thing, you might be thinking to yourself, Zach, the Project Explorer, that's kind of cool, but it still kind of doesn't solve the clutter problem. I still have a ton of layers, still not very organized. Well, coming eventually into this Project Explorer will add different ways to organize your data, like folders and stuff like that. But the tree is still a problem here. So let me actually make my way to this guy. So what I can do is go to the Project Explorer, and we're adding this new thing called, we haven't really figured out a name for it exactly yet. I'm just going to call it maps because that's what they are to me. But they're a lot more than just maps. So if you're familiar with Arc Pro, you kind of have one big project, but within the project, you can make different maps and add different layers to those maps that you then save for use later. And that's not a functionality we currently have in RAS 6. But in RAS 2025, we are trying to add something similar to that in. And so in the top left, I can actually add a new map. And so I'm going to add a new project view. And the project view is what everyone is familiar with. So I have two maps open. And you'll notice I've clicked on the left map and the terrain is on and the result is on. If I click on the right map, nothing is on. But I can turn a geometry on and zoom into it and see the two maps side by side. But Zach, this still doesn't solve my clutter problem. The tree is still this big bulky tree. And so what we're going to do is add a number of different smart views. So for example, one of those, I can actually right click on a plan and click focus in new view. This is going to open up a new map with just the layers in my tree that the terrain is using. And so hopefully, if you're working on a plan, this will be really easy to declutter the tree. Now, sometimes you need more layers than what I auto added here for you. And so what you can do is you can go to the Project Explorer. Let me actually close my map, bring this guy over here. You can go to the Project Explorer, and let's say I want to add a result to this map. In my Project Explorer, I can expand out my results bucket and drag a result over to the tree. And now I have access to the result in the tree and can animate it. And so we're hoping that this sort of control where you add what you want to be interacting with to your tree, to your map, it becomes a more primary workflow. And so we're kind of trying to integrate this into not just maps, but also charts. And so I have a profile line. Actually, I guess I don't on this one. I can just draw a profile line. And I can plot a result. And then, so this is plotting the half cell size result. What I can do is I can just drag another quarter cell size, or another one of my results for my quarter cell size geometry over to the tree, turn it on, and it will now also show in the chart. And so this will also not only be a way to organize maps, but also charts and many things across the UI. And that's it. Those are some of the new cool things we just added and will be in the next release or two of the RAS 2025 alpha. And that's it for me. I think I'm sending it back to Alex.
All right. Thanks, Zach. Uh, Sorry, let me toggle my video here. I wanted to make sure that we leave enough time for questions. I know we've been getting a lot of awesome questions in the chat and in the Q&A, but if there's anything specific we should address, I want to leave some time for that. So I wanted to just close out very quickly at the end here with a call to action. What can you do to help us, and how can you get started with the software? So from the software itself, we have, when you have a model open, help. You can launch into our announcements, documentation, and our website. And that should take you to our main launch page. Download, getting started. YouTube page, Stan's been really good about adding YouTube videos on how kind of usability, how to use the software. And this has our approximate roadmap. Our software development is difficult and famously timeline slips. So this is a fairly aggressive roadmap. We are trying to do a lot within the next few years in terms of what we're going to be delivering with the software, how quickly we can kind of tackle the back catalog of features from version 6 that we know everyone needs to continue to do their work. And how you can help us, right, is if you are using the alpha and if you have experience a bug, please help and say report a bug. That's also accessible from the main screen bug report here. This really does help us out. So if you have a crash, if the mesh generation doesn't work how it seems like it should, if something doesn't seem intuitive, this is a really, really good way for you to help us by reporting bugs in the software. If you toggle this geometry or mesh generation bug as checkbox as well, it'll give you an option of selecting a geometry. That'll upload it to us. It attaches log files. It does everything that we need to help diagnose the issue. We've had 600 or 700 kind of bug reports at this point. It has actually helped us fix hundreds of bugs. This is a really, really good way to kind of provide feedback and help support the development. With that, I think that's about it from our end. And does anyone have any, or I guess I'll throw it back to the presenters. I'm not sure how you guys want to handle questions here.
Yeah, cool. Thank you, Alex. So there've been, let me just preface this. We do have a few minutes left, so we'll take questions if they come in. We've had a ton of questions come in. If you asked a question, it's probably got an answer in writing. So go ahead and check back in that Q&A area, and you'll probably have a customized answer to your question there. So check that out. In the meantime, I am going to launch another poll. It's just sort of like a rating of our webinar, so you can kind of let us know how we did in just kind of a quick, simple way. So if you wouldn't mind doing that. And yeah, we've had it since I've been talking, even we've had a couple questions come in, and they're already getting answers typed to them. So that's great. Let me see. Mark has a comment here. As always, so many good things coming out of this. Alpha was requested not to be used in production. Is the idea that 1.0 will be stable enough to use in production when that's available?
Yes, I'll type this out as well.
Okay, thank you.
That, of course, is our absolute goal. We want to make sure it's stable, but that necessarily means limiting the feature set. So we understand that the wealth of 30 years of software development means that everyone has some reliance on some small niche feature. Everyone has a different 2% use case. So our 1.0, we expect people to be using RAS 6 for many, many years to come as we slowly fill out that backlog. But yes, we are going to be working quite heavily on stabilizing it and making it ready for production use.
Okay, wonderful. So we're kind of getting questions piecemeal here. We'll take this one out loud. Is it possible to import your own land use shapefile with corresponding n values? That comes from Michael, so he's wondering about that.
We definitely have the vector drawing features, and I'm pretty sure we have that hooked up to the polygonal importer. Zach might be able to weigh in
Yeah.
on that.
You can in the classification importer, similar to the terrain, there's a green plus button. You can either click that and add a raster, or just drag your classification raster onto the classification's green plus button, and it will add it.
Okay, wonderful. Well, we'll wrap up there. We'll give you back a few minutes of your afternoon. Just a couple reminders before we get out of here. Credits, certificates of attendance, a copy, a PDF copy of the Q&A that we've received. We're going to send all that out. It's going to take us a week. So kind of middle of the week next week, you'll get an email from us with the information about that. But yeah, just want to thank you all for our attendees for taking time out of their afternoon to stick with us and join our training. And then obviously, Zach, Alex, Cam, the whole team on your end, Christy. I know you did a lot to put this together too. So thank you all very much for sharing this with everybody. It was definitely a very sought after topic. So got some really great comments and just really again appreciate you taking the time out of your busy schedules to share this with our group. So um, that's it for us today. Thank you so much, everybody. Have a great rest of your week. Take care.
Thanks, Kevin.